We'll just wait for a few minutes and then start. Before we start, I can take some questions if you guys have. And I have a sore throat today, so apologize if the audio might be a little muffled today. Okay. Yeah. Okay, I guess we can start. Um, so last session, we saw about inline operator. So as in, it's more of a keyword again. So you qualify your functions as inline to optimize away the body. Okay, so that's essentially the idea. Now, you can get the same effect if you use the add macro. Okay, so in this case, we saw an example with the add function where the input is x and y and the output that we want is just x plus y. Okay, and since the body of this function is very small, we sort of want it to not exactly call the function, okay, but rather just replace the body in the place where we call the function. Okay, now as we saw before, you can do this in two ways. One is the add a macro itself, and second is adding inline to your function itself. Now, the main difference to note here is that while the type is checked here, so whatever is the input of add function, so let's say both of them needs to be integer and the output is also an integer. So this is enforced. Okay. Nothing of that sort is enforced in the macro. You could have passed different data types, and if they can be added, okay. So if it is possible to add them, this will go through. Okay, so essentially this line will go through. Okay, and there will be typecasting to C because it's an integer. Again, if that is possible. All right. Now, the important thing here is that it's possible that it will compile or it will throw an error at the compilation itself. Okay. It's possible that while all of this might be allowed, as in addition of certain two data types and the conversion, it might not be the intended effect that you would want. Okay. So ensuring the data types of both XY and the output is much more cleaner. Okay. Hence, preferably use inlines. All right. Okay. Next, we saw the reference uh, operator, essentially the ampersand. Okay. The idea is that when you pass variables, either they're passed by like a copy, so a pass by value or pass by reference. Okay. So we saw certain examples here. So for example, let's start with the main itself. I have the a vector of integers a. I have the vector of integers c, right? Let's say I just write all values to it. I can write a for loop for it. Okay. Let's say I want a function to do the same. I want a function to do the same thing, but this time, I also want to reuse that function. So I'm writing this function void. Okay. It is supposed to take a vector, right? And essentially writes all the values to it. Pretty straightforward. That's what we want. Okay. This is the intended behavior. Okay. But if I pass a to it, and let's say this is not a reference, then what happens is a b gets copied from a. Okay. And essentially the scope of b is inside this two brackets. Thus, what you get is a b which is temporarily existing only inside the function. Okay, so its size does get allocated, okay, because of the copy. And when you write the values to it, it does get written, but not to a, okay, but to the b only. And when you it goes out of scope, it gets destroyed. Okay, so again, this is not something that we intended because we want to be written to a. So in this case, what one can do is actually pass A as a reference. So having the extra ampersand here essentially means that we're passing A, okay, when you're calling this function A, whatever parameter you're passing, so in this case, a standard vector of integers as A and named as B here in because for the scope of the function, they are a reference to each other. Essentially, B is a reference, means in terms of memory location, A and B share the same location. It's just an alias. Okay. One can essentially think of it that way for references. All right. Now, when you write values to ith values of B, okay, you're also writing to the ith value of A because they're one and the same. So reference essentially takes care of the intended behavior that we wanted, as in writing values to the vector A. Okay. Other way one can do is, let's say we wanted, sorry, say we wanted B of certain size, as in only pass set function. We define the set function such that we only pass the sizes. Okay. Now, instead of uh, void data type for set value, okay, we can also have our data type for the A vector itself. So which will be standard vector integer. So what we can then do is pass the size, okay, define a B, write to it, and just return that. Okay. And then define A as in this manner and using the set function to return the B. This also works. Okay. Only thing you're doing is the number of elements you want to set, you're just passing it. You can even avoid that also because you can just set value here inside. But this is more little more general, so hence done this way. Okay. And in either case, if you try printing it, also, yeah, that also works. All right. Okay. So essentially, that is reference where uh, any data structure in general, it need not be a standard vector also. You can create a reference to it. Okay, in general, in C++. So when you pass any parameter as a reference with some data type, okay, whatever may it be, that becomes a reference. Okay. And then we started with object-oriented programming, which is about classes. Okay. Very important concept. So the syntax of defining a class is something like this, where we use the class to define a complex, use the class keyword to define a complex class, where I define a public region where two doubles, real and imaginary, are defined. Okay. And we also define a function called norm. Okay. Uh, the idea here is that the class complex serves as a blueprint for any point in the complex plane. Okay. So every complex number has a real part and an imaginary part. All right. And we can sort of define a norm for it, like essentially the distance from the origin. Okay. Which will one can define as standard. I'm using the square root function from standard library. Okay. Where you multiply the real times real and add it to the imaginary square. Okay. Square the real, square the imaginary, add them, and take the square root. That's essentially the norm or the distance from the norm. If you think of uh, complex numbers as a vector, this is like an L2 norm, or you can think of them like the distance from the origin itself. Okay, all right. So essentially, now this class serves as a template for all the future uh, complex numbers that we want to define. Okay, now we define a specific complex number this way. So let's say C is the complex number C is also called as the object of this class. Okay. Whenever we have a user-defined data type, like a class here, okay, and when you instantiate any object like this way, okay, and or essentially define an object or define a variable of that data type, the variable is called an object. Okay, so C is an object here, and with this syntax, you can sort of define what the real and imaginary are. So later on, we saw about constructor. So you okay, and because real and imaginary are public, I can access those variables outside the class. As in, I can do c dot real or c dot imaginary. Okay, and even the norm function is also public, so I can call that function outside the class, right? So printing them, we see these values. Very similar to that, we can also define more and more complex numbers, C1 and C2, where the real and imaginary parts are given this way. And printing the real imaginary parts corresponding to C1 and C2, we get the corresponding outputs. Okay. Building on top of this, we define something called a line class. So which needs the complex class, which we use from the previous example here. And on top of that, we define something called a line class. The idea is to show you guys that complex class, while was built on default, like the inbuilt data types, like the double, you can use the user-defined data type, like the class itself, which you have defined previously, to define the members of your another class. Okay, so a line will consist of 2 points, right? Uh, so here I'm using the complex class to define one end of it, so the point A, another end of point B, and we can also define the length of this line, okay, which will look something like this. So essentially, we are taking the difference between the real parts, squaring it, okay, and adding to the difference of the imaginary parts, square, okay, and then take the square root. Very similar to the previous one, we define the points P1 and P2, right? Both of them being complex, and using them, okay, P1 and P2, I define the line class, which let's call it L0, okay. Furthermore, we can also check what's the length of it will be. So printing that gives this answer, and then we define the square where square in the xy plane, that one of the endpoints is on the origin, okay, and the square is of size just one unit. It's just a unit square. Okay, all right. And furthermore, this it shares its sides. The square shares its sides with the axis of the x and y axis. Okay, so sort of should paint you guys the picture of how the square looks like. Okay, so starting from the line one, so the first endpoint for the base will be at the origin. Okay, so this is the side of the square, which is at the along the uh, the axis, x-axis. Okay, so one endpoint will have 0, 0, and another endpoint will be at 1, 0. Okay, and then the next line segment will be parallel to the y-axis, starts from 1, 0, and ends at 1, comma 1. Okay, and then the next one, it's parallel to the x-axis, starts from 1, 1, ends at 0, comma 1, which is on the y-axis. Okay, and then the final one, which is along the y-axis, starts from the 0, comma 1, and ends at the origin 0, 0. Printing this length confirms that the size is indeed 1. Okay, all right. Next, looking at constructor, another important concept of object-oriented programming, where you can also it's essentially just give me a second. Yeah, a constructor is essentially a function that is called whenever you construct any object. Okay, so here in this case, when I can just call C2 and not pass anything, so it will use the default constructor. But if I use C1 and then pass it within this brackets, it's sort of like calling a function, right? So in this case, the constructor of your class will get called. You can set default values. So if you don't pass anything for that, it considers it to be the value again, default value. Okay. So if I'm passing 1 and 2, it will take underscore real and underscore imaginary as those two values and set, and then the furthermore there is more syntax to the construct. So the first one, it sets the real as the value of the underscore real, which is 1 in this case, and image as the underscore imaginary, which is what you pass as 2.0. Okay. And both real and imaginary are members of your class. This in this case, I've made them private. Okay. So that you cannot access these values outside the class. Okay. But to check the consistency again, I'm printing the norm, which I make sure that this which I make sure that this is public. Okay. So you can call that function outside the class. Now remember your constructor, or as you guys see the destructor even, both needs to be public because otherwise you won't be able to call that function outside the class, right? So another important thing is that constructor is called when your object gets created, and whenever the object goes out of scope, okay, the destructor gets called. The job of the destructor is to clean up all the space taken up by your object. Okay, all the member variables and everything gets cleaned up. That's sort of the idea. Okay, and finally saw that this operator as in THIS, which is here. Okay, the idea is that this is a const operator pointing to the current object. So let's say I have my class which has members x and y, and I have a public function like a function func which is public a and b. Okay, which I can use to set some values. Okay, simple enough. So essentially, it sets the internal member variables of x and y through outside. All okay. Now, let's say I have my class object obj. So this is constructing the class, right? And I define P and Q, which are 10 and 11, right? To set the internal objects, I use the the function, which is called on the object, okay? And I pass P and Q. So the values 10 and 11 are passed and X and Y are set accordingly, all right? Now, the this operator, you can also explicitly say, if I want to use X equals to A, like as in set X as I can do that, like I'm setting Y. You can explicitly say that I'm accessing the X owned by this object itself. Okay, and setting that to A. Absolutely fine. This is also, these two are equivalent. Okay. Now, because it is inside the class, the function has access to even internal member variables. Okay. So here X, you don't need to access it like very explicitly like this, but then again, it's an option. Okay. Another important thing, if the access specifier like public or private is not mentioned, here in this case it will be private. Okay, this is the default behavior in C++. Now, let's say I so again there's a question last class. What if you have why does this operator needs to be constant? So this operator essentially points to the current object. Okay, very much something like this. So let's say I have the my class object obj, but instead of a proper object, it is a point to the class. So object obj will only store the address, okay, pointing to the actual class. To call that uh, object, one can use the arrow operator. Okay, now the this operator this is essentially this guy obj, whatever obj is, because obj is pointing to the object of my class. This also points to the same object, same object. Okay, difference being this is not constant and while this is constant. Okay, so you always know what is the current class you're working with, right? So that is the use of this operator. But let's say I have object obj like this with some data type. I can always typecast it, okay, and change it to store something else. Let's say I have object one of my class. I have object two of my class data type. Okay, I can essentially interchange them, those two. Okay, that is allowed because these two are not constant, right? But internally, the object ones, which your object is pointing to, and whatever object two is pointing to, their respective THIS operator, okay, will store their internal uh, address anyway, which will be correct. All right. I hope you guys understand the difference here. THIS will always store its current object, the address of current object, while you might define classes this way and let it point to some object, right? You can later on actually interchange them. That is also okay, right? But when you work with the class itself, PHIS will always know that it is pointing to the current object. Okay, right? Any questions so far? Okay, that is, let's look at more example. Another important thing about classes, let's look at that. So I'll take the example of complex class again. Let's have the private variables, bubble, real, yeah, and imaginary. Public members as previously saw. Let's write the complex constructor, which is double real. Let's call it zero. Yeah, double imaginary. Call it miscellaneous. Will be defined as real. Imaginary defined using imaginary. Okay. Yeah. And in the constructor to say that it actually got um, constructed, I'll just have it pretty much from the last time, and the destructor too, pretty much the same. But you don't need to pass anything actually to this. So we saw the norm function, which I'm not going to write. Then maybe for completion, let's write that also. Okay, this is the norm function. What I wanted to add is that this is what we saw last time also. Since the members are private, okay, you can actually set some use functions called getter and setter functions. So what are these? So basically a getter function looks like this, where let's say you say get real. Okay. Essentially gets the real part of your complex number. So you keep your variables as private, okay, so that they don't get modified later on outside the class. Okay. And if you want to read that value, you only use the getter function like this. Okay. So this something like this. Simple as that. So to read off of values, like the real part, you have to use the function itself. Okay. It uh here the cases the variables are small in number, but in cases where you have very large classes, okay, where you want to only restrict access to reading of certain values, you can do something like this. Okay. And another one, setter function like this, where I'm setting the real value to some real value I'm inputting. So real equals to underscore. Okay, yes. I'll just make a note, get a function. It's a setter function. All right. I'm not writing the main class, which you guys can pretty much free from the last time. Okay. Today, let's look at another very important keyword, which you can qualify any of your variables. That's the static object, static keyword. So what is this? As usual, I will first include the my stream. Define my class. So let's say integer x. Okay. Again, this will be private. Remember, default variable. So public void function. Let's say it just says sets is equal to 50. Okay. Print function x as x plus 5, and then prints it. So notice there is a variable function sets it, print updates it again, and then prints the value. Okay. That's sort of the idea here. Now let's go with the main class. Sorry, the main function. I need to have some my class objects. Okay, let's call them ABC, and then a dot function, a dot update. Okay, So pretty much similar. I'll have B, and then C. Okay. Now, yeah, I've not introduced any static yet to get across the point. So can anybody tell what will be the outputs? So if I run this code, let's try doing that actually. Uh, Yeah, okay. So I can run this code, but anybody wants to take a guess what will happen? Okay. One says garbage. Okay. Why do you think so? I mean, if any explanation for that? Object is not initialized. Okay. Right. Well, if you think about it, the object ABC uh, will, when it's called, they have their own copies of X, right? And the only way to uh, currently there is a prescription to set X using the function func. Okay, print updates it and prints it. That's it. So technically speaking, objects A, B, C are initialized by the default constructor. Okay, so X will be defined for all of them. So let me run this and show you guys the output. Okay. They all print 20, right? I'll just comment these parts to maybe illustrate this further. Oh, okay. So my bad. Yeah. So let's say I would have printed then after this function that then for A, the X is set to 15. For B also, for C also. Okay. Even if it's not set initially, calling the function func sets X. Okay. And then when we call the print functions, okay, then the sec X inside A gets updated by 5, which was already set to 15, so it's 20, right? And then that gets printed. That's what we get as the output. All of them 20. Okay, right? But what if you do not set it some value and then just print it? Okay, you do not set to anything. So, like I said, it's some garbage value, as in X, it because we don't set X to anything, it will be some value, whatever is there in the memory, right? So hence we get this. It is some number and it was 5 was added to it, okay, and then printed. That's it. All right. Okay. But this time let's go a little further and define X as static. Okay. What does static mean? What it means is there is a certain X by which is part of this class, my class, which is shared by all objects. I'll repeat that. So when you say a variable is static, okay, and it is a part of a class, so whenever you define any object, okay, of that class, all of them share the same variable x. Okay, that's what static means. Important thing to note. This is again part of the C++ language itself. When you define something as static, okay, you have to initialize the variable also. So one can do it this way. So because it's integer, I'll say integer. Use the class name as the namespace. Okay, access s x there. Set it to 0. So the variable needs to be initialized. Okay, all right, and yeah, that's it. Then you're good to go. Okay, now let's look at this example. So if I set call the function a, yeah, that's it. Let's just keep it this way. It's 20. That is expected because the behavior of x per se does not change if it's shared, and even if it's not shared, like if it's shared by only one object, then the behavior is the same. If it's the local object or the shared object, right? So here in this case, func is called first. So x is set to 50 and print is called again. So it is updated by 5, which is 20, and then gets printed. So that's the output we get. So far, so good. Okay. But what if I set this value and then print it? What do you guys think will happen? I'll repeat the behavior of x again. 25. Okay. That's a good attempt. Let's see the value. It is 20. Yeah. So again, remember, while x is the same, yeah, exactly. It's redefining. Correct. I wouldn't say redefining, more like resetting. It's the same x, remember, which is shared by both a and b. But when you call func, okay, it sets the value. It just resets whatever value it already had to 15. Okay, the difference between this static case and the non-static case with this example, okay. So essentially, if I have this case originally case one, where I have just have integer x without the static and have this whole code currently, let's call that case one, and case two with static and all of the rest of the code remaining same. The difference between these two cases is that while the output in both these cases will be 20 for x, okay, the difference is that both the x were part of two different objects. In case one, they were different. In case two, which is static, they are the same object. Okay, I hope you guys see the difference. The difference being, while func sets x to 15 and print updates it, okay, while that happens both in A and B, in the case one, without any static, the variable that gets updated in func and printed is different for each of the objects. So the first case, it is a x belonging to A. The second, that x belongs to B. Okay, but if I have the case two, which is static, okay, then A, the x that gets updated in func is the same x that gets updated in func of B also. Okay, but because it gets reset by 15, and then when you update and print, both of them print 20. Okay, now if I do not reset it, I think you guys can guess what should be the answer now. Actually, that's actually the one the answer was already done. So let's just confirm that. Yeah, now you get as 20 because we set x to be 15 first, and then we set we update 15 by 5 and print it. So that's the 20. Then we update the print using the print function. We update it by 5 again and then print it. So the value currently holding in X, which is shared by both A and B, is 20 at this point. Okay. And when you call the print function, it it updates it by 5 again, so 25, and then prints it X. So hence you get as 25. Okay. I hope you guys get the difference. Okay. Then you guys can play around with all these combinations more and more and see what each of the output will be with static and without static. Correct? Again, the important thing to remember with this syntax is that while if it's a private variable, you do not need to initialize it to anything. But if it's a static variable, you have to initialize it to some value. Okay. All right. Now let's take this also again. Any guesses? What will be the output for this? Remember, this is a static X. Yeah, it should be 30 because we did not set it to any other value in between. So every time you call print, okay, it updates the existing X, which is shared by everyone. All right. So you can technically call A again here, right? And then will be another print value, which will be 35. All right. Now, what if I have this? Then what will be the output? Remember, X is static again. Yeah, output will not be just 25. There will be multiple outputs. Yeah, right. 20 and then 20 again. So remember, the print function prints every time there is every time you have a print function, you get an output. So you should have four outputs because there are four print functions. Yes, that's correct. It's 20, 20, 20 and 25. That's correct. Okay. All right. Any questions so far? It's not the value of ABC because ABC themselves are objects, right? So the small letter a that you consider as an object, it has a member which is X. So that X gets updated. Yeah, that's the thing. Point of declaration, no, you cannot. You have to declare it outside. Reason being, because it is shared by everyone, you can only declare it after your class itself. Okay. Yeah, right. So it's more correct to say that it's not the value of ABC that gets updated. It's the X owned by this ABC that gets updated. Here I did not make them as public, but you can access this X of A, of B and C as A dot X, A dot B dot X, and C dot X, and then check the output of those. Oh no, it's definitely useful. It just happens that to understand a static variable, which is owned by all these objects, uh, we just use the static. So for example, you can have like a flag, which is owned by all objects of or instance of that class, right? And they all are on the same page because it's a static variable. And that flag will decide what will be the behavior of the class at any point. It's possible you might have different objects of that, but let's say that flag is a static variable. It decides how or which path your function of your class will go. You can cook up some function, but this is a general direction one can you think of how to use this static object. Okay. Another useful case is you can have static functions where you essentially make a collection of functions inside a class. So you give it a name essentially, right? And the useful thing then you're doing is you don't need to define the instantiate the class itself with an object to use those functions. Okay, you can just directly call those functions. That's another usefulness of static functions as such. Okay, so for example, stream. Let's say my class is my class. This one just it's a very simple one. It just prints some cross code. Okay, right. Now, because this is a static function, you do not need to instantiate an object. Yeah, sorry. Instantiate an object to call this function. You can, like, usually you need to do this, let's say object, and then call object dot func, right? You can do this. I mean, there's nothing wrong with that. But when the function is static, you do not need to do this. Yeah. Is a private member. Yeah, sorry about that. Let's make them public first. It will throw it will print that function was called. Okay. But because it's static, I do not need to do all this. I can actually just do this way. Okay. So you can call the function itself by not actually declaring the object. The reason to do have such a thing is objects themselves take space, right? You have to instantiate them and they take space. So there is a overhead in dealing with objects. But if your function is a static function, you can just directly call the function as such. You don't need to have uh, memory associated with your object. Okay. So again, relating back to the this operator, there is no this operator in static functions, like in this case. Okay. All right. And I hope the so this is static function, and here we saw static variable. Okay. This I hope this is clear why we'll have multiple objects but sharing the same static variable. Okay. All right. Let's take another example. Okay, I'll need another header file here in this example. That will be the string header file. It's essentially you're dealing with a string of letters. That's the hence the string header file. Okay, let's define y equals to some 500. Let's say, and I have let's say main function which will have let's say yeah this way. So I want to print y. Is this allowed? So I wrote a code where I define the variable y outside the main, okay, and I call it this way. Is this allowed? Okay, no. Let's see the output. Uh, I do encourage you guys to at least attempt because even if it's wrong, it's completely okay because this is a learning stage, right? So we also guys learn why certain thing is certain way and why it is not in the other way, right? So it's always good to attempt, right? It prints 500. So I see two answers. Let's see that. It prints 500. So again, the reason here is that the y is in a global scope. Okay. And so when something is in a global scope, inside any other smaller scope, you have access to that variable. Okay. If I had defined, yes, that's a scope variable. So here it's global scope. If I had defined integer y equals to 0, okay. So what would have happened is I have another y here, which is in the scope of this, right? So the y that I'm trying to print here will be this guy, not this guy. While yes, there is a sort of name collision here. You have a y here and you have another y here. This is sort of allowed because this is inside this other scope, right? So let's try to print it. Now it prints 0 because y is another variable. In the context of all this, while this y is the global scope, this y is in the local scope. And the local scope variable takes precedence, and that's what gets printed here. Now, the question, then there is a ambiguity, not ambiguity, there's an inconsistency. Like I said before, the global scope variable should be accessible everywhere, right? So if I have another variable, is it like I'm redefining this y? No, of course not. I'm actually defining another variable. So as in, so as to say, this y here is different than this y, right? But if I am able to access only this y, how will I be able to access the global scope y, right? So there is a prescription to do that. If it was not available, then you will have the then the fact that global scope y was accessible everywhere will not hold, right? So just because you are able to define another variable of the same name in local scope should not prevent you from accessing this variable in the global scope, right? So to yes, exactly. So to access the global variable, use the scope, but as in the namespace. But it just so happens that the global scope has not been given any namespace. So we just use the empty namespace, okay, and use a double colon and just access y through it. Okay. Okay. The question is, let me just print this and so that this gets clarified. Yeah. So the first y that we gets printed because it is in the local scope that takes precedence. So when we say y, it actually means this y. Okay. And when we use the double colon, it refers to the global scope y, which is 500. Okay. The question is it possible to print y as 500 always. even if we define another y equal to y3, as it is said that y is global variable, it should always be 500. Yeah, that's the thing. So even if you define y0 as 1 or 3, okay, your local variable is what that gets changed. Okay, you're actually not changing the global variable here, right? So that's why when you print with double colon, you always get 500. And when you print with y, you print the local variable. Okay, does that clarify the question? Yeah. So if you print this now, you get 3. Okay, just give me a minute. Okay. I hope this is clear. Does that answer the question? You can change the global variable also. I think this should be possible. Let's see. Let's say we call it roll. So now when you print the global variable y, you get as 4. Okay. Yeah, that's a good one. So you see, when we say variable y or in the global scope or in the local scope, there is a uh, tag that is used by C++ to distinguish them. Okay. You can think of it that just that way. How is it exactly implemented is uh, I think will be beyond the scope of this session. But essentially, you can think of this way. When you define a variable y in the global scope, there is a tag associated to it. When you define the same variable y in a local scope, there is another tag associated with it. Okay. And when you call y, the precedence is always taken for the local variable. That's how we are getting it. Okay. And when we want to explicitly access global variable, we use a double colon without any namespace because this is in some nameless namespace. You can think that way. So I set the value to be 4, and when I print it, that's how I get it. Okay. Uh, Does that answer the question? Okay, so we'll build on this. And that's define a data class. Which has this string s. Let's call it ID. And this will be private. So part section of the data class, then the public section. So first we construct the takes ID underscore. Okay, that's its own ID using ID underscore. Okay, and then we have just to say that it got constructed. Now the important reason I'll why do you even have the ID, right? Will come now. Is we're creating that too. Furthermore, we write the destructor too, which just prints when the destruction of this cut of a certain ID gets called. Okay. Now, this is the data class that we have. Okay. Now in defining my class, which will now involve static members of data class. So we use data D1, D2, and D3. So I define another class where the members are D1, D3. Each of them is of data type data, and all of them being static members. Now, again, important thing, because these are static members, right? So they need to be initialized. So we will do that. My class. So remember, D1 is a data type. So data type, the namespace my class of D1, like this, you have to do. Okay. And then pass some string because the data, sorry, the data constructor itself expects a string, right? So you pass that. So something like first object, yeah, to correspondingly second and third. Okay, right. Now let's say I run this what do you call it? This code. What is the output that you guys expect? Just take a guess. I'll not make any other change to this code and just run this. Do you guys think any output other than these guys should appear or not? Right, 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 right. That's correct. Because we actually um, create like initialize a class, right? Because we have class here. Initialize its object because that's the static variable. And when initializing a static variable, D1, D2, D3, right? We are doing it, right? That that will happen. Each of them is of data type data, right? And data being itself a class, its constructor will get called. So you should expect to see even these constructs getting printed. Okay, right, that's correct. So let's print that and check. Um, sorry, my bad. I think this is three. Yeah, correct. Interesting to see that the values 3 and 4, which are first encountered in main, they appear later, right? But the construction gets appeared first, right? That's an interesting thing to note. Meaning, first, when so this have to remember something about C++, it goes from top to bottom. Yes, right. and then calls the main as the first function, right? But the static members, right, they get initialized first because of the global scope, right? So if you want to think in this way, functions getting called does happen, but the first function that gets called is main, which is true, but the variables setting, like global variables like this, happens first. So the static members initialization happens actually the first, like it takes precedence, right? So D1, when it's past first object, that gets constructed. Okay, so D1 of data type. So that's the static member. So its constructor gets called. So construct first object gets called first, and then second object, and then third object. I think that is clear. It's straightforward. And then we get the Y and Y global, Y local, and Y global. Okay. And finally, when the program ends, the static member variables also go out of scope. Out of scope because they're in the global scope. That global scope also ends, right? Hence the destructor gets called, right? Now, if you see the order, one might think that the order here might just as well be random, but it is not. What I mean by that is the order in which the construction appears, okay, and the destruction appears. The construction is first, second, and third, right? And the destruction is because D3 goes out of scope first, then D2, then D1, right? Hence, the destructor prints D3 first, then D2, then D1. Okay. Now, what if we interchange these two? It should pretty much print the same number of lines, right? We did not change anything of that sort, but the ordering in which this appear may change. What do you guys think? Okay, do you guys think it will change, right? This answer yes. Okay, let's print it and see. Yes, indeed it did. Okay, so what actually happened is the second object gets called first because again, the constructor, this is how it was initialized first. First D2 was initialized, and then D1, and then D3. So second, first, and third is in the order in which you get the constructor appears, right? Okay, but the order in which the destructor appears is the opposite. Again, pretty much similar behavior as to the last one, where we have the third object going out of scope first, then the first object, then the second object, or D3, then D1, and then D2, right? Okay, so this ordering is something we saw now. What if we have this? Right, so we can expect sort of predict what will be the output. Okay, let's print this and see. So second, third, first. So that's the order in the of the construction. Destruction. D1 goes first, and then D3, and then D2. Okay, right. I think all consistent so far. Data is a constructor or copy constructor. No, it's just a plain old constructor. Yeah. Data just initializes D1, D2, D3. Yeah, that's the data type of D1, D2, D3, and them being static variables, we just had to initialize them in the global scope here like this, and yeah, that's it. It's a simple plain old constructor being called, and then destructor may happen as the code ends. Okay.
Oh, so instead of reference operator, if you remove it, does it still work?
Reference operator.
This is standard string and percent.
Um, it should. Oh, okay. Right. No, that's the important thing to remember here. Uh, the ID gets overwritten, but that is of data type, and each data should have its own copy. The my class has different D1, D2, D3, which is shared. So you can actually just try this out. Uh, right. So let's go back to the original example where we had first object, second, and third, right? And let's we just remove that. Yeah. When in doubt, just print it. Okay. It sort of actually works. I think the reason it is fine. Reason being, each data object has its own copy of ID. So when we have the copy, sorry, when the constructor gets called for the data, the ID underscore gets copied from the string, which is this guy, and we set it to the ID. So D1 has its own copy, D2 has its own copy of ID, and D3 has its own copy. Now, my class object, let's say we had an object created of my class, we did not do anything of that sort. If we had created that object, then the D1 and D2, D3 would have been shared by all the objects of this my class because they're static. But the while the D1 is shared, it is different. The X, sorry, the X I'm saying, yeah, in a way, X only. The ID of D1 is different from the ID of D2. That is still the case, right? So yeah, when we construct it with the ID, hence we see the differences. We can test this out. Yeah, right?
Now let's say if we add the same another line
Yeah.
at line number 11, the original one with ampersand.
Okay. Yeah.
Now keep this also, and then there is another line with ampersand. Which
Yeah.
one get called?
Yeah. Okay. So I think this will be problematic because what do you call C plus won't be able to figure out which to call actually. If it's ambiguous, then it throws errors. But let's see.
I think
Yeah,
the second one
yeah, it actually throws errors. So the reason being that yeah, that's what it
ambiguous.
says also. It's ambiguous.
Okay.
Yeah, you can actually if you think about it, if you call functions, this is like calling a function. Let's not worry about it's being part of a class, constructor, and all that. Essentially, a constructor is also a function. And when you pass a variable to it with the same signatures like this, right? Them being just differing by a ampersand or a reference or a copy, right? There is essentially no way for your C++ program to know which one to actually call, right? Because it is not obvious to us. I think it's not obvious to the program also, but to the compiler. Uh, when you have this ambiguous like mm, calls, that's when you get this kind of error. Yeah. Okay. That's good though. I mean, thinking in different directions like this, it um, pushes you toward thinking how deeply does each component of this works, right? So is the part of the constructor, the classes, the reference, so on and so forth, right? Yeah, that's good. Any other question? Okay, so let's keep the construction as D1, D3, right? But this time, let's interchange these guys. Will anything change? That is the question. Okay, let's now, okay, you think it's will change? Okay, let's print this. So you see that the order in which the constructor gets called is still following the order here. So first, second, third, and the destruction follows three, and then two, and then one. Okay, let's think these two and printing. So first, second, third as the construction, destruction, three, two, one. Okay. We can maybe do it this way too. Or did I do it? Yeah, let's take it this way. So again, it's the same first, second, third, and then three to one. So yeah, to do all this exercise, there is a important point to remember that the allocation while you define a static object like this, okay, it says that the memory will be in the order of this. Okay. As in there is a variable called D3, D2, and D1. Okay. Which will be there in the class, my class, a part of the my class, and they are static. As in they will be shared by all the classes, all the objects of this class. Okay, that's fine. Now, when you actually again, they have another requirement then you have to initialize it. Okay, we just do that. Now, because you're initializing in this order, that is the order in which construction happens. Right? Destruction also happens in this order because you initialize in that way. The order in which you actually declare them has no role in the order in which they get destroyed. Okay, right. That is the important thing to remember here. If you have any other order, it still follows that order, opposite order of the construction. Okay, all right.
Sir,
I
it
think
is because they are
Mhm.
declared static, or
Yes,
so if we do not declare them static, and then the order depends on how the data members are
yes,
declared, right?
yes, that's correct.
Okay.
Because they're static and the initialization happens like in this global scope in this way, they have a certain order in which they get destroyed also. Constructor, I think it's obvious. The order in which you call the actual constructor should be the way it should print. That is, I think, obvious and straightforward. But the way in which it gets destroyed, that might not be so straightforward looking at it. But again, one can argue in which way they get destroyed. Simply knowing that how does uh, memory allocation of this happens and so on and so forth. That's the idea I'm getting at. So second, first, third, that's the output you get. And the reverse order, third, first, second, is the destruction that happens because that's how the memory was allocated. Okay. So the order in which you declare the static member variables has no or does not affect the order in which they get constructed or destroyed. Okay. Because constructor gets called only when you initialize them. That has not changed. And destructor is essentially going out of scope, right? Which also happens because of this one, right? Maybe I'll just have it in some order. So, yeah. Right. And this was covered. So yeah. Right. Um, yeah. If you guys have any questions, you can feel free to ask. But yeah, I covered the topics that I wanted to cover today. Yes. Yeah, question. C string is mostly commonly used, then the string class. Then is a oh yeah, uh, it's just that string class is specific to C++, and you can use the C string in again C both C and C++. So that's the only reason it is more common. That's it. There's no specific reason as such. Yeah, but again, it's definitely more useful if you use string class because again, it's a class. So it has all the niceties that comes with a class. Member functions, very useful member functions. Uh, it has its own constructor and destructor. So again, memory allocation and all those things you do not need to worry about. So all these niceties come automatically using predefined classes like from the STL library, right? So yeah, me personally, if you're what I would suggest is if you're writing C++, go ahead, absolutely use all the STL template libraries from the header file, like in the standard template library. Yeah, they're extremely useful. Any other questions? Oh, actually, that's a good question, I guess. Uh, See, the reason to for any language is that it has its own use case, which for which it was developed originally. Okay, so for example, uh, if I may take example of C and then why C++ exists. So it's like see, you have object-oriented programming, right? And classes and objects, and then polymorphism, and then inheritance, which we will be seeing as more advanced features building on. classes, like why classes, right? That's actually the one of the reason why C++ exists, because you have classes and all its niceties that come with it, which were not there in C. Okay. And you essentially get the same speed. Okay. And all the memory management that you can do with pointers and such. So that's the reason C++ exists from C. Now, the reason Python exists is it's easy to prototype, quickly prototype anything. You do not have to worry about strongly typing your variables. And there is a garbage collector, which will take care of all that. So when you're prototyping anything, it's easier to quickly prototype something in Python. In that sense, the learning curve is also a lot lesser, right? So keeping all these things in mind, each language has its own like advantages or disadvantages, so if one might say. Now, with the advancement in AI, one thing I have to remember is uh, while the generation of code, okay, while you're writing in any language, but your AI can help in either way. So uh, if you're writing Python code, it can help there. If you're writing C++ or C code or even Rust, it can help in those cases also. So from the perspective of writing code, it does not uh, really matter what you're writing. If the AI is, let's assume it has been trained in all those languages you're trying to write. So you'll get your code, initial baseline code or some sort of template code, right? Blueprint of your whatever thing you want to implement from your AI. The other thing to remember is that while building the AI itself, so that was the use case of AI after it's been built and all those things. While building the AI itself, you have you have to train it on some large data sets, right? And remember, you have to do a lot of certain calculations while training the AI. Those calculations are internally like, sorry about that. While all the libraries which are written in Python are used to train these AIs, right? In the backend, they're actually written in very fast languages like those by C, C++, or Fortran, because essentially those are library. In the backend, they call these libraries which are been uh, industry standard. Okay, they have been used for a very long time, and they were originally written in these strongly typed languages. So, um, what I'm trying to get at is strongly typed languages like C or C++ are not going anywhere. They will still be used. Okay, it will just so happen that they'll be used for uh, like expensive and critical operations. There you absolutely need to use these languages. Okay, in using the AI as a tool, like I said, it could be for any language that you're writing. I hope this sort of answers your question. Okay. What I'm getting at is the relevance of C++ is more or less uh, in especially there. You can essentially write everything in C++, but it is mostly there when you want very performance critical applications. So let's say you have writing your own library. You want it to be as fast as possible and extremely scalable. In those cases, it does make sense to write your code in C or C++. Yeah. C++, one might prefer it because of the, like I said, all the capabilities that come with C++. Yeah. Yeah, thank you. Thank you. I hope you guys enjoyed the class. Yeah, thank you. Okay, this question on CPA project. Okay. So yeah, lambda functions I'll cover in subsequent classes. Yeah. Um, if you want to take a look at any how to put it, C++ project looks like, you can look at any of the open source projects. So, for example, I can't name certain way, but you can find in GitHub. So, let's say a certain project is open source and written in C++. You can see the source code as to how they organize as the main function, and then subsequent related files into different folders. Okay, there'll be a header file. There'll be just a folder just for header files, and you can dump all your header files there. You can then separate your different CPP files in different folders, so on and so forth. That's also you can do. And topics related to like C++, like more specific to object oriented. I'll be covering friend functions, inheritance. Okay, where you're deriving from a parent class. That is an important one. Polymorphism. Other than that, I think yeah, more or less these topics. Lambda functions, smart pointers. Yeah, these are the ones which come top of my head. But as we go, I'll be also covering some of the other more important topics. Yeah, yeah. Thank you, thank you. Thank you. I hope you guys like the class. Yeah, do practice. That's something I always say. The more you actually go through the code, write it yourself, see why a certain line works and doesn't work, gives you more clarity on the topic. Yeah. Okay. See you guys next week and happy coding.